A block of mass m slides down the plane at an angle 30 degree with acceleration, it's g by 4, my bad, g by 4. The value of coefficient of kinetic friction will be. So the flow chart, as usual, to assume this problem, what would that be? We'll visualize the concept, the question. We will set the frame of reference, identify the system, isolate the body, and then go for sigma fx and sigma fy and find out the unknown. So let us first visualize this. Angle 30 degree, inclination, a block of mass m is sliding down. Okay. Now when the block of m is sliding down, we know that this weight can be resolved into two components. One is mg sin theta and the other is mg cos theta. You may have a doubt how. Let's quickly go through the resolution also. So we have and slope theta. Weight of this block is acting downwards. I'll take this vector. Weight is acting downwards. Well, essentially it should be acting from the center of this, right? It should be acting from the center of this, but it being a vector, I can displace it, right? So just keep it over this place. So we have the weight vector here. This angle is theta. Weight was acting perpendicularly, so this angle is 90 degree. So in this triangle, let us say triangle DAC, 90 plus theta, this angle will be 90 minus theta. One weight, okay. Now, how are we resolving this? That's also important to understand. We are resolving it into two components. One, which is perpendicular to it. Perpendicular to what? Perpendicular to the inclined surface. And the other, which is parallel to the surface, right? So we have two components. One, which is parallel to the surface. Two, which is perpendicular to the surface. So since this component is perpendicular, we can say that the angle between these two components would be 90 degree, and therefore this angle is 90 degree, right? So we have this angle to be 90 degree. Now look at this complete angle here. This complete angle here, since the vector is perpendicular, this complete angle is 90 degree, right? One portion of this is 90 minus theta, and therefore the other portion should definitely be equal to theta. So in this triangle ABC, we have this angle to be theta. So triangle ABC, we have this angle to be theta. And if this is theta, what is sine theta? Opposite by hypotenuse. What is opposite? BC. Hypotenuse, which is AC. So what is BC is equal to? So sorry, So what is BC is equal to? BC will be equal to AC into sine theta, right? BC will be equal to AC into sine theta. What is AC? AC is mg. So we have mg sine theta is equal to, what is BC? We can write BC as horizontal component of weight, right? Horizontal component. So what is mgx? Is BC, which is mg sine theta. What is AB? AB from this equation will be AC cos theta, right? So we have AB is equal to, instead of AC, we have mg. So that is mg cos theta. Now what is AB? AB is otherwise the vertical component of weight, mgy. So what is mgy? It is mg cos theta. Now coming to the given question here. The vertical component is mg cos theta. The horizontal component is mg sin theta. Okay. So we have visualized. We have set the frame of reference. I will choose it to be inertial frame of reference. Okay. And now let us find out the system. We have the system, the overall system here. Let us isolate the body. I have isolated this body here, and then we go for sigma fx and sigma fy. Let us see how. So if you observe in this block, there is one component which is mg sin theta, which is the horizontal component. Vertical component mg cos theta, and since this is in contact with the surface, there will be a normal force, normal reaction acting perpendicular to it. So now let us apply sigma fx is equal to ma and sigma fy is equal to 0. So you may be asking, why is sigma fy is equal to 0? Because there is no motion. Why is sigma fy is equal to 0? Because there is no motion in the y direction. So displacement in the y direction is equal to 0. Therefore velocity in the y direction is equal to 0. And therefore acceleration in the y direction will be equal to 0, and if you multiply this by m, m into ay would be equal to 0. And what is m into ay? It is fy, and therefore sigma fy will be equal to 0. What does it mean further? It means further that forces acting in the up direction would be equal to forces acting in the down direction. What are the forces acting up? The only force acting here up is normal reaction. So we have n is equal to what are the forces acting down? The only force acting down here is mg cos theta. So we have n is equal to mg cos theta. However, sigma fx is not equal to 0 and sigma fx is instead is equal to ma. Why? Because there is motion only along the horizontal direction. And along the horizontal direction, we have two forces. One, which is mg sine theta, and two, which is mu k into n. Now, you might be asking, how do you take this to be positive and the other to be negative? Let's understand the concept as well. So, the overall direction of this motion is towards downwards, right? So, all those forces which are acting along the net direction of motion. So, the net direction of motion is downwards. So, all those forces which are acting on the net direction of motion would be taken as positive. All those forces which are acting against the net direction of motion would be taken as negative. Let's do that one more time. So, this is the net direction of motion. There is one force acting along it and another force acting against it. So, that force would be taken as negative. The acting one along would be taken as positive. And since mg sine theta is acting along the direction of motion, we'll take mg sine theta as exactly as positive. And since kinetic friction is acting opposing or acting against the direction of motion, we'll take that as negative. Now, what is kf? Kf is mu k into n, right? What is kf? Kf is right over here. So, what is kinetic friction is equal to? It is equal to mu k into n. But what is n? N is equal to mg cos theta. So we have here, instead of n, we can write here mu k into mg cos theta. Now, all of this being equal to ma. So now I'll divide this entire equation, right? I'll divide this entire equation by m. So we have m by m, mg by m, and ma by m. So m by m is 1. So what we get is g sine theta minus mu k into g cos theta is equal to m by m is 1 is equal to a. Now what I'll do is, what is acceleration? It is given in the question that acceleration is equal to g by 4. So now we have g in all three terms. So we'll divide this entire equation by g. G by g is 1. So we have g by sine theta as sine theta. Mu k to g cos theta, g by g is 1. So mu k cos theta, g by g is 1. So we have 1 by 4. So sine theta is 30 degree here. So sine 30 is 1 by 2. Cos 30 is root 3 by 2 is equal to 1 by 4. And minus mu k into root 3 by 2 is equal to 1 by 4. I'll transpose this 1 by 2. So this becomes minus 1 by 2. So minus mu k into root 3 by 2 is equal to 1 by 4 minus 1 by 2. I'll multiply this 1 by 2 by 2 and in numerator and denominator. So what we get is mu k into root 3 by 2 is equal to minus 1 minus 2 by 4, which is minus 1 by 4. So minus mu k is equal to 2 into minus 1 by root 3 into 4, which is minus 2 by minus 4 is minus 2. So what we have is minus mu k is equal to minus 1 by 2 root 3, and therefore mu k is equal to 1 by 2 root 3, which gives us the correct answer as 1 by 2 root 3, option B.